welcome to lesson 1.7 on continuity. Just to remind you where we are in the unit, we're here. We've got 2 more lessons left, and then your test will be next week on Monday and Tuesday. All right, so in this lesson, we're looking at actually a really important concept in calculus called continuity. A lot of other theorems and things are based on knowing whether or not a function is continuous. Okay, so informally, a function is continuous if you can draw it without picking up a pencil. Right, so you see this function here, I can draw it, continuous. This one has this jump here, not continuous or discontinuous. So if it has a jump, a hole, a vertical asymptote, something like that, then the function's not continuous. Formally, how we define it is if a function is continuous at A, if all 3 of these conditions are met. F of A is defined, meaning the function exists at that point. The limit as x approaches A exists. So the limit from the left equals the limit from the right. And those 2 values equal each other. The limit equals the function value. If any of those conditions are not met, then the function's not continuous. Okay, so you need those 3 things to be true. So if it's not continuous, it means one of these things must be true. Either f of c is not defined, right? So here there's a hole and there's no other point. So the function is not continuous at c because f of c is not defined. Here, the limit does not exist at c because the limit from the left does not equal the limit from the right, so the function is not continuous at c. Here, the limit exists because the limit from the left equals the limit from the right. The function is defined, but those 2 values do not equal each other. Therefore, the function is not continuous at c. All right, so let's go through this example. Identify an x value c where f of x is not continuous based on each of these reasons. So f of c is undefined. So I'm going to start all the way on the left. Define, because there's a closed circle. So it's defined here. Define, open circle, and there's no closed circle anywhere at -3. So c equals -3 would be one place where f of c is not continuous because the function is not continuous because f of c is undefined at that point. Okay, here, even though there's a hole here, there's a closed circle here, so the function's defined. Keep going. Closed circle, we're good. Okay, here, at c equals 5. The function is undefined because there's only holes, open circles. Okay. The limit as x approaches c does not exist. So let's see where that takes place. Limit from the left does not equal limit from the right. So c equals -5 is discontinuous at that point because the limit does not exist. Limit exists. So remember here, the limit from the left, even though there's a hole, the limit exists. Okay. Limit exists. And then c equals 5 is another place where the function's not continuous because the limit does not exist. So actually, there's 2 reasons for at 5. Okay, the last one is saying if the limit does exist and f of c is defined, but they don't equal each other. All right, so that occurs here at c equals 0 because the limit as x approaches 0 is -1, but f of 0, where the closed circle is 0. That also occurs here at 4. Because the limit as x approaches 4 is 0, but f of 4 is +2. All right, so go ahead and try the check your understanding. It's a matching activity on the Nearpod, and then I'll meet back with you.